Okay, got to remind you where I left off. I believe we left off, we were talking about safe pigs. But you guys already know safe pigs because we've been talking about safe pigs from the very beginning. So we should whip through this with my help. So there are a couple of things on your calendar. You may have something that pops up that says you have a 300 word formal lab report. So I want to talk to you guys about the formal lab report. Dan, can you hear us? Because I just want to make sure that you guys are able to hear as well.
Well, listening.
Yeah?
Yep.
Okay, good. Okay, so that date says it's due on the 4th, which is a holiday, right? So it's actually not going to be due on the 4th, it's actually going to be due on the 11th. So 7 days after, so we need to do that next Monday. Now, the formal lab report is going to consist of a couple of things. Okay, so this semester you guys are going to have a total of 3 formal lab reports to turn in. These formal lab reports are going to be worth 300 points. The main purpose of the lab reports are to get you guys used to writing scientifically. So a lot of you guys will be going into some form of either healthcare or science. So you guys need to get in the habit of documentation. Learning how to document things, how to write things, how to be brief and concise, because I don't like reading many novels, especially if there's lots and lots of students. So then it gets kind of dry after a while. So the very first thing that you're going to do, you're always going to give the title of the report that you're doing. So the very first one is going to be the Mentos experiment. We're going to be collecting all of that data from all of the different ones. For those who are in the online class, you guys, your very first experiment or your first lab was the M&M lab. So in your case, you guys are going to be collecting all of the data from the M&M lab. Now, when you go through and write this, you want to just, as I said, put the title. The first thing that you put after the title, you're going to put the purpose of the lab. So what was the purpose? What were you supposed to get out of it, right? Be brief. You don't have to tell me, 8 pages or anything like that. Really short and brief, okay? So then the next thing that you want to do is, in all of your cases, in both your cases, since you guys are using scientific method, you guys should have hypotheses. So you want to sit there and state your hypothesis, clearly state your hypothesis. If you have more than one, you can list more than one. It's okay. Okay? The next part is the procedures. You want to write down what you did, right? And again, be concise. You don't have to make it hard to read, make it simple to read. The next part is the data and observation. So you guys remember the data that you guys collected on paper, on your lab notebooks, right? Or on the lab handouts. So that is the data that you're going to be putting onto you want to literally take that data, that raw data, that should be included on your lab report, right? So then that way, if you have investigators, they can go back and look what you did initially, right? So it gets you in the habit of putting down what you're supposed to put down generally. And then the next part is called the results and calculations. Well, the results are what you do to make everything look pretty. So those are going to be your graphs. That's going to be explanations of your graphs, right? So you want to make sure that you distinguish between your data and observation. All of that is raw. That's what you're taking down real quick, right? When you guys are out there, you probably see soda on it and all that stuff. All you need to do is sit there and take a small picture of that and put that into your documentation, right? So normally you have a lab notebook that you keep everything in. You keep all your notes, all your observations, everything that would go there. That's what you normally do. But we don't do that as much anymore since we're doing everything digitally. So now what you're going to do is just incorporate that digital image of it. So we have a copy of that raw data. Now, anytime that you're in the sciences, you're always going to have somebody that's going to be going through your notes, right? There's called checks and balances. So if you say something, let's say you're working with a patient and you're keeping track of this patient's vitals, all of that has to be documented, right? Now, you may take those vitals and start making graphs and everything with them to present to like your bosses and say, well, this patient probably needs better care than we're providing based upon these vitals, right? But you're going to start off with that raw data, and then you're going to make it so that they can understand your point. So that's what the results and calculation is about. It's to make your readers understand what you're saying. So that's where you're going to use your graphs. You're going to be using, graphs like pie graphs. You're going to be using bar graphs. You're going to be using line graphs, and you're also going to use tables. And sometimes you may need a figure to sit there and explain those things. Okay. So the other thing that you want to do is you want to specifically answer any questions that was asked in the lab. So you want to make sure that you answer those questions in the results. Now, when you go to the conclusion, your conclusion should be a brief summary, because a lot of times, if you have a lot of things to take care of as an instructor or as a boss, what you're going to do often, and you trust your employee, right? So then you're just going to go to the conclusion and get the conclusion part, because then you're going to use their conclusion in your report that you have, right? So in this case, all you're going to do is briefly restate the purpose of the hypothesis. You want to be even concise in what you were earlier, right? So you want to make sure it's really, really concise. You guys know what I mean by concise? Short. Don't give me any knowledge. It's not, I don't want you to sit there and write me, 2 books, It needs to be concise. As scientists, you want to be straight to the point, right? You don't want to fluff it. So then you want to evaluate your hypothesis, because you basically just told me what your hypothesis was. Were you right? Were you wrong? And if so, why do you think you were wrong? If you're wrong. Okay? If you're right, well, you can sit there and you can make reference to the results that would explain why you were right. Okay? Any questions that you didn't answer up in your results, you want to make sure that you specifically answer in your conclusion. Right? So if I look at your results, and I'll be looking at your conclusions primarily when I'm in a rush. So those are the things I want to make sure that you're definitely getting down. I'll go back, if I see something kind of crazy, I'll go back and look at your data, your observations, and I think something they here, especially if you didn't say why something went wrong, right? Things are gonna go wrong. If things don't go wrong in the lab, then you're not doing a lab, right? So there's gonna be always something that's gonna go wrong. That's just the way the world works, okay? You may drop a piece of hair into your experiment, and it may affect something. You may spit in it, and it may affect something. You may knock over the something, right, and knock something. That's unfortunately what happens in labs. If you're doing things are going to happen. That's the way it works. So it's okay to be wrong, but you need to recognize that you're wrong, and you need to sit there and tell me, hey, this is probably why these answers were kind of whacked up, Questions? Concerns? I'm so excited today. Okay, so there are going to be occasions where you're going to have to identify unknowns. Okay? What do I mean by unknowns? Anybody want to help me out with that?
If the soda was left out longer than it should have been.
If the soda was left out longer than it should have been, so that wouldn't be an unknown, that would be a reason. That would be a reason why. So that would be kind of like, number 2. Well, that's the reason why they didn't go as high as I thought it did, was because the soda was left out too long, right? Or somebody didn't put the cap on it. Okay, so that would be. So when I make reference to unknowns, if you're going to be identifying unknowns, that basically means that I give you something that you have no idea what it is. But through experimentation, you determine what it is, right? So you may be looking at the color, the weight, the density. And so using those things, you basically identify what that specifically unknown is. So in that case, when you're identifying unknowns, the first thing that you want to tell me is typically they'll give you a number 1, or sample A, or sample B, something like that. You need to tell me that unknown code or number, right? And then you tell me what you believe those unknowns are, right? And what I would always do, I would say, my first instinct based upon the data would be this. But I would always have a backup, because I hate being wrong, right? It's just like you guys, nobody likes to be wrong, right? Right? Even though my ex-girlfriend, not girlfriend, my ex-girlfriend used to tell my mom like 99% of the time. So I got used to that. Okay, so it's okay, but have a backup. Think about it. What is the other alternative? So I believe it's this. This is my first belief. But alternatively, it can also be this. You know? Does that make sense? Does it make sense? Yeah, I know, it's like 8 o'clock in the morning. You guys haven't had coffee yet, right? Okay, here's the next thing. If something went wrong in the lab, you want to explain the source of your errors, kind of like earlier. Well, I spit into it, right? It didn't spit into it. I was talking so fast and the spit just came out. So it probably was something that reacted with my spit, and that's why it turned green, but nobody else did it. Right? That would be an explanation. Pretty simple. Okay. And then the last thing that you want to do in your own words, tell me what you learned. What did you learn from the lab? Not to spit in my sample, right? Okay. Make sense? What did you guys learn from the mental side?
The mental level in the morning, high pressure, so the person very very hot.
So if we were hotter, it was hotter today, it was better than today, it might have been higher.
Kind of like heat experiment.
That sounds good. So then I would suggest that as temperature increases, reactions increase. Okay. That, I'm buying that. I'm writing on to it, I'm gonna check. I'm gonna check it. Yeah, that's good. That's good. Okay, so you want to show what you learned. Pretty simple. What about you guys that are new to the M&M lab? I think the answer is just you, so you gotta say. Or Layla. What did you guys learn from the M&M lab? Well, hopefully they learned something. We'll follow that on later on. Okay, so the last thing is, I always give extra credit points if you guys put the link to a video that you guys put on YouTube or you put on TikTok, right? So if you send me that link, and I have to have access to it, it can't be private, because the whole purpose is that I want people to seeing you guys doing the experiments. So did you guys record the experiments that you guys did? Yeah? So what I'd like you guys to do is upload a little bit of the experiment that you did, explain what you did, and then you guys will get extra credit points added on to your file. Okay? So if you sit there and you think about it, right? Think about it. So you have 3 formal lab reports. So that's 6 points of extra credit that you've already added on to your file. That's pretty good. 6 points just by advertising the class. Okay? Questions? Concerns? Cash? Okay, so that's what your formal report is going to be about. What does it do again? It's going to be due the 11th. Okay? And in both situations, for the Mentos lab and for the M&M lab, you guys don't worry about the M&M lab. They have to worry about the M&M lab. Okay, so they're both dealing with scientific method. So the data and how to write the formal lab report will be posted on the Canvas shell. So we're gonna have you guys, all you have to do is you watch the video and it will take you through the whole process. So the process of entering all the data, because we need everybody to enter the data, and I'll give you the time that data has to be entered. Okay? And then to write the report. It takes you specifically through each of the steps to write the report. And so that's both for the M&M lab, they have their own, and you guys will also have your. Okay? I have to make some modifications to it to repost it. So. Questions? Concerns? No concerns? Anybody want to give me? Yes.
Is there a word count limit on the written report?
There isn't a word count limit, but if you guys start giving me mini novels, then I will start giving you a word count limit, you know? So the key is keep it concise, short, concise, right? You know, make sure you hit all of the major points and that you've not left anything out, but be concise. So if you watch the video, I'll show you exactly how to do that. Okay, questions? No questions, good. Okay, so let's go ahead. Start back with sig figs. Okay, so when we talk about significant figures, we're mainly talking about uncertainty, right? So we've already talked about that. I talked about my weight and everything like that, the force scale, the Richter scale, all those things, right? So, so when we sit there, we think about it. Let's say, for instance, we had a graduated cylinder. I'm going to draw it on the board so you guys can actually see it. Okay, so this is a graduated cylinder. If we had a graduated cylinder, and you guys see where the water level is at, actually, probably less. Okay, so the fluid is about where it's located at. The fluid represents the little line that's drawn like this, the black line.
22.
Okay, so you said 22? Yeah. Okay. Anybody else? So the first thing that I want to say is when you're looking at a graduated cylinder or a beaker or some type of measurement device, you're always going to be looking at the meniscus. The meniscus is the part at the very bottom. That represents the meniscus. That tells us where it's located. Okay? Now that you know that, what would you say it's at? You say 21? 21 and a half. Say 21 and a half. So we got 21, 21, 25. Anybody else want to take a gamble? What else? No one else? That's it? Okay, how many people say 21? Let's just do it like that. Everybody's got to talk. I need you guys to start interacting. I got two saying 21. How many say 22? How many say 21 and a half? Anybody not vote? Everybody voted? Okay. Okay, so now the one thing that we can say definitely, what can we say definitely? What is the one thing that we can definitely say? That you feel confident. You can say that it's not 22. Okay, so it's not 22. Okay. Is it exactly 21? No. So it's not exactly 21. Is it somewhere between 21 and 22? Yeah. Okay, so we know, so then in other words, you're telling me that it definitely has that 21, right? That's that 21 something. So the thing that we're significant about, that we're sure about, is the 21. That's the thing that we're like, yeah, I know it's 21, right? And I also know it's somewhere between 21. Not quite 22, but it's greater than 21. Right? So your significant figures in this case is going to be what? What are you sure about? 21, right? So you're sure about the 21. So in that case, how many sig figs are you going to have? You're going to have two, because the last one you're not sure about. You're like, it might be half. It might be a little less than half. It might be a little bit more than half, especially based upon my drawing. Third grade drawing. Nice face too. Yeah. Okay, so we're not sure about it. Okay, now that's what I'm talking about in terms of uncertainty. So in this case, we would have two significant figures because that's what we're sure about. We're sure that it's 21. We're not too confident to say definitely it's 21.5, because it's like, maybe it's 21, maybe it could be 0.4, right? We can't tell from my drawing, okay? So sig figs helps us with that uncertainty. So it just makes sure that we can state what we can actually say without going over, trying to state too much. Does that make sense? Yeah. You guys look so tired. You would think that you only had 3 hours of sleep. I don't think so. Okay, so we also have the concept of exact numbers. There are times that we know exactly it's this, right? So a lot of times when we use things like, we're gonna use 1 cup, right? So it's exactly 1 cup. So then in that context, then that would be an exact number, right? So there's uncertainty associated with it because they tell you how many cups are you supposed to use? 1, right? So that would be an exact number. So then in that case, you don't have to worry about sig figs, right? Because you have an exact number. Does that make sense? Because literally what it's saying is that if you want to be really exact, you say it's 1.0000000, because it's exact. You don't have to worry about it, you know? So you don't take that in consideration when you're working with sig figs. So if it's an exact number, you don't have to worry about it. Does that make sense? Okay, so we have leading zeros. So up top, you guys take a look. Let me get my little pointer. Okay, so these guys here, these guys are leading zeros. In this context, these zeros are not going to be significant, right? They just help us define the value of the number that we're looking at. They let us know that it's a very, 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 very small number. Okay? But those non-zero numbers are going to be significant. So then how many sig figs do I have in this? I know it says it up there, but you guys can help it. How many? 2? Okay. So in the other context, again, those are leading zeros. They let us know how small that number is, how many sig figs do we have in that case. I know it's up there. Okay, I want you to say it because it starts to stick a little bit better. Even though you see it written up here. I want you to say it so you think about it, right? Okay, so, and also I want you to make sure that I'm right, because I could be wrong. I could put any shit up there, and you guys, we're just gonna take it for real, right? Okay, so the next thing is lagging zeros. If there's no decimal point, those lagging zeros are not going to be significant either. Okay? As soon as you put a decimal point, if I put a decimal point, I'll put a decimal point right there. How many sig figs would that be? 8. It would be 8. Because in that context, I'm saying that I am sure about those zeros that are before the decimal point. I'm 100% sure about it. That's why I put that decimal point. Okay? But before, if I didn't have it, we know that it would be 4, right? So, again, here, it's just 4, right? It's just those non-zero numbers. What about the next one? 5, because it's the non-zero numbers. So the next type of zero that we have are called captive zero. When they're between 2 numbers. Anytime that you're captive, you're going to be significant because you're stuck. You have no choice. We know that that's real. Okay? So, how many sig figs do we have for 10100? Okay, how many do we have for the next number? What's that? 20 million and 70,000. Okay, piece of cake so far. Now, as soon as we start adding those decimal points and we start putting zeros behind it, then it makes those numbers, those zeros significant. That decimal point is gonna be valuable because it's telling us the fact that you put in that extra work, that those numbers are important. Right? Because you don't need them, you're not using them to keep value or to keep, you know, the place. They're there because you put them there, right? They're not required, but you put them there. So that tells me immediately that you're saying to me that they're important. Okay? So, you guys want to test this out? I'm gonna put a couple on the board. And then I want you to tell me how many sig figs you have. Okay, so we're determining the number of sig figs. Okay, so can you guys see my decimals? Decimals. Is that better? Okay, A. How many sig figs do we have? Significant figures. So how many? Anybody agree or disagree? Everybody agree? Okay. B. Everybody agree? Anybody disagree? C. Agree? Everybody agree? Anybody disagree? D. And E. How many? Three? Everybody agree? Anybody disagree? You don't write anything down. Oh, so somebody did disagree. Okay, so we want to remember these zeros here, those are just placeholders. They let us know the value of that number, right? The zero that's following here is significant because we took extra time to write it. Because technically, numerically, if I wrote it as 0.0013, these are the same value, right? Numerically, right? You put an extra zero there, that lets me know that they're important, right? So, but these guys are just helping us, I forgot a zero. These guys are just helping us keep the value, right? Let us know that that's the value. It's not 13, it's 0.00013, right? Make sense? Okay. Any questions? Online, are there any questions? Any concerns? So this number here, how many sig figs do we have here? Okay. So we're doing addition and subtraction. Do you guys remember what we need to do? Right from the left. Okay. we're gonna be looking towards the left, the closest one to the left. So we wanna first draw our lines to figure out where significant ends for each of our numbers. And then we go to the one to the left, right? Okay? So, let's go ahead and draw some lines. Oops, that's not what I wanted to do. Okay, so where does significant ends? So we're gonna start with this problem right here. You guys see mine? Okay, so where does significant ends for that very first number? Tell me the location. Is it after that first zero? Is it after the second zero? First zero being if we started from the left. Where does significance end? Gosh, we just talked about it. How many sig figs do I have up there for that very first number? First number, you said how many? Don't put money up. 4. Okay, so tell me the number, which numbers are significant? Is that first 2 significant? Is that the first 0 significant? This one right here, I'll point to it. Get my pointer. This one, if I can get over there, that one right there. Is that significant? Okay. Is that 1 significant? Is that 2 significant? Is this 0 significant? Okay, so significant ends after the 2, right? Because that 0 following it isn't significant. So we're going to draw a line there. Okay, now what about the next number? 230. Where does significance end? After the 3. Okay, what about 12,000? Where does significance end? That's after the 2. And then 10. Where does significant end? After the 1. Okay, everybody sees that, right? So we draw that line. So you said we start from the left. Okay, so if we start from the left, okay, so it's going to be right here at this line right here, right? So let's go ahead and add it up. What do you guys think? So what you guys got when you added it up? Okay. Okay, so then we're going to take a look at the right side of the line that we're going to be choosing. So we're choosing that green line. For those who may be colorblind, it will be, we'll call this A and B. So we're choosing line A. So this is our choice right here. Okay? And then we're going to look at the number that follows that line. So if that number is greater than 5, what are we going to do?
Round up.
We're going to round up. So if it's greater than 5, we're going to round up. If it's less than 5, what are we gonna do? It's gonna stay the same. So the number next to it is gonna stay the same. Okay? And then if it's exactly 5, it's gonna stay the same. Okay, have any of you guys ever been on a seesaw? It's also called a teeter-totter. You know, a little thing where kids sit on it and they go back and forth like that? You've never been on that? Okay, so you know there's a park back over this way. They have one. You should go. You should go with somebody that weighs exactly what you weigh and somebody that weighs more than what you weigh. Okay, and somebody that weighs less than what you weigh. Okay, so if you guys are exactly the same weight, then it's going to be completely balanced. So nobody has more of an edge, right? But if you weigh more than the other person, what happens? The light person goes up, right? Until you push up to make them go down, right? But then eventually it's going to come back the other way. They don't even have to push. It's going to happen, keep coming the other way. So then what's going to happen is it's going to go in one direction because you weigh more. So you're going to cause it to go up, right? So it's the same thing like a teeter-totter. 5 is our breaking point, right? If it's exactly 5, we're kind of stuck there, right? So that means that we're just going to say, oh, it's just this number, right? We're not going to round up, okay? So when we do that, this value here now is going to be just 32,000. And we're not going to put a decimal because if we put a decimal, that means that we're telling people that we know that those zeros are real zeros. Based upon this, we don't know if these are real zeros, right? The things that we're sure about is just the 32. Here, because there's so much uncertainty wrapped in that one, we're not sure about it. Really, this 0, it could have been a 1, it could be a 2, it could be a 3, it could be a 4. Right? It can even be a 5, exactly. We don't know. We're not sure. And so because we have that uncertainty associated with it, we can't say anything about these values here, except that we know that by adding this up, this is a 3, but if this is a 5, that's going to really change things, right? But if it's a 1, it's not going to change things too much. Right? But we don't know enough about that 0, what that 0 really means. Does that make sense? Okay, so we have to account for it. So in this case, it would be 32,000. Okay, so now that I've done the first one, and you guys can help me. So mean, look at that, so mean. I'm gonna go back and cry a little bit. Now I want you guys to do the next 3. They're gonna be exactly the same way, whether it's addition or subtraction. Okay? Go team, go. And you guys can discuss with each other. Yes?
Why did you pick the 3 to see if it was above or below 5?
So you always want to come over here to the left to find your line that is nearest. So in this case, the 12,000 here has more uncertainty associated with it than all of the other numbers, right? So in other words, we don't know anything. I'm pointing here. Do you mind if I point using my, so that the people online can actually see? So that 12,000 has more uncertainty associated with it because we don't know if that 0 is a real 0 or if it's not. Because somebody just wrote 12,000. They didn't put a decimal point there, so we're not sure about that too, right? So because it has uncertainty associated with it, that zero really could be a 1, right? It could be a 2, it could be a 3, it could be a 4, right? It could be any of those numbers, we don't know. Okay? Because of it, we can't say anything about the certainty of this. The only thing that we can say is that we know we have a 3 and a 1 there, right? And we add those two together, we're certain about those because they have numbers following them, and they're also non-zero numbers, right? We're sure about that. So then we can use that to determine whether we can round up or we can leave it alone. Because if it was greater than 5, then it would be closer to 33,000. If it's less than 5, it'd be closer to 32,000. Right? Does that make sense?
Yeah.
Shake your head. You have questions? You sure? Do you have questions? If you don't understand, you gotta say something, because it does no good for you to sit there and just don't get it, I'm just gonna just pretend, yes.
Why did you put 33,000 instead of 33,400?
Why did I put 33,000?
Yeah. Or is that 32?
That's 32,000.
I can see that.
You guys, my bad, I'll fix it for you. I'll actually, let me type it so you guys can see it typed rather than my 3rd grade handwriting.
I think what I meant was, why didn't you put the second paragraph after the 32?
Because we don't know really what they are, right? So that's why, so that was kind of what she was asking, right? So let me see if I can explain this a different way. Okay, so the answer is 32,000. The reason why it's 32,000 is because we look at this number, right? This the 12,000, right? Nobody put a decimal after the 12,000. So that means that we don't know anything about these zeros right here, right? So if I can get we know nothing about those zeros. Okay, so those zeros are unknown to us. Okay, so we don't know if they're really 0. It could also be 1, right? They could have just made a quick estimate. Oh, it's about 12,000, right? And so if we took them as being real, it could hurt us, right? So we want to let people know that we're not sure about it, right? So since we're not sure about it, we can only do the best that we can do. We can only do what we know, right? So these numbers here, we're sure about those numbers because they're numbers, right? So somebody took the time to write 1, 2, up here at the very, so 20. They took the time to write those numbers. So we know for sure those are real, right? So we are going to take that into consideration.
So if a number has a decimal, that gives certainty?
Yes,
Okay.
by putting a decimal, you're telling me that it's certain. But if you don't put that decimal, you're telling me that you don't know, right? You weren't sure about it. Your piece of equipment is limited, right? That's what you're telling me. So the first thing that says, like if we were talking about weight, this was weight that they were doing, it would tell me that their scale isn't accurate, right? And so they got 12,000 pounds, but that's the best thing that they can do. So they might have done it 4 times. One was at 0, one was at, following it. So it tells me that there's no certainty associated. It loses that certainty. As soon as you use those zeros and you don't put a decimal there, you're telling me it's not clear, it's not certain.
Okay, that makes sense.
Okay?
Okay, so how many things like
Uh-huh.
so will we go with like 5 stick bits? Because we're doing the bottom, there's a 5 and what's at the top, there's a 2.
It depends
So,
the number of significant figures, right? So for the final answer, or are you just talking about, for the final answer, you just have to use the line in there, right? Because if we looked at this, like say in my problem, the first one that I did, how many sig figs do we end up with? With 2. So you use your lining up because you're only as good as the numbers that you're using, right? So in this case, because that 12,000 was so limited, right, in terms of its certainty, then I can't say more than that. It's what limits everything else, right? So you're only as good as the number you're using, right? So if you're using all your numbers, then you have one that's really uncertain, that's gonna be the one that you're gonna, okay? Okay, so you guys have some answers. Yeah? No? Maybe? You discuss it with each other, did you guys find it out here? Yeah? No? So now remember, you have a decimal point, right? So you want to correct the decimal point, right? Then you put your decimal there. Okay, so what is uncertainty? Okay, so in this case, uncertainty and after this is that's what you draw like here, right? After that. Because these are, they have decimals in front of them, so remember, these are just placeholders. So they're not gonna affect the same things, it's gonna be after that. Okay. No, you better put mine here. After this one, after that, you have to put one after that. In this case, you'll put one after that. Okay, you guys at least have the upper, the upper one done? Oh, no, the decimal doesn't tell you, say that you're blind. The decimal is just where the decimal is, so this line should be erased. So we want to determine where does uncertainty end, right? Not where it begins, but where it ends, right? So put your decimal so you can make sure that you keep everything aligned. Okay, so then, in this case, we look at this, okay, so where does certainty start? Okay, so then now, what's happening? Are we sure about that? Okay, this is one. So then uncertainty would end right after that. You don't need to follow. Okay, so then here, where does uncertainty end? That's what starts. Where does it end? After the one, so it's the same one. Okay, so what about this one? Yes, and then here, where does it end? Are these after the three? No, remember, these are capped. Anytime there's a cap, it's capped, right? So if it's in the middle of the two numbers, it's always going to count. So then it's after. Okay, so then, this is the one that I love the rough, right? So go ahead and do the math. I get where you got something. Okay, so let's do the top one. We'll go through it together. Okay, so if we take a look at this number here, the very first number. So it's 0.000011. Okay, so where does significance start in this case? It starts it starts at the one, right? So this is the first significant number. Then the second significant number, and then significant ends after this number. So we would draw the line right after the second one. Okay, so it'll be right here. Okay, the next number. Where does significance end? What number does it end at? After the one, okay? So it ends right here. So we draw the line again at the same spot. Okay, so then what about 0.011? Where does it end? After the second one. And then our last number, where does it end? after the 3. Okay, so this is line A. This is B. And this is C. So which line am I going to use to just determine where I'm going to be rounding? A. I'm going to use line A. So then I go after line A. So, anybody add this up for me? Anybody did all the hard work for me? No, come on, somebody.
0.016.
So you said 1.0, and you said 16. 5, 1, 2. Okay? Okay, so we're gonna go after line A, right? So we're looking at the number after line A, which is a 5. Is it exactly 5? Is there any numbers following it? So we have 5. Are there any numbers after that 5? Yes. So then that means it's not exactly 5. That means that it's more than 5, right? Okay. So if it's greater than 5, then we're going to do what? We're going to round up. So then my answer should be, I'm going to type it because my 3rd grade handwriting, you guys are going to think it's 12 and it's. Okay, so my final answer should be 1.017. Did everybody get that? Got a question?
But like, if it wasn't 5, it would stay the same.
If it's exactly 5, it's supposed to stay the same. So if we look at the numbers afterwards, that's a 1, that's a 2. So it's kind of like you're saying 5.12. Would that be greater than 5? Let me write it down so that you can see it visually. And then you're going to tell me if it's greater than 5. Okay, so if I had a number that is 5.12 and reversing 5.00, okay? Which number is greater? 5.12. So then that means when I say you're saying it's 5, you have numbers following it. Anytime you have numbers following it, it automatically pushes it up. Okay? So does that make sense? Okay? Does that make sense over here? No? Okay. Well, I like honesty. So if I give you $5, right?
Well, I understand what I don't understand is, why is it like the 6, not the 1?
Why is the 6 not the 1?
Yeah.
Because it's where the one that gave us the least amount of significance, right? So this here, this number, this 3rd number, sorry, I need to remember I have people online, so. Okay, so this number here, right? Significance ends after that part. So in other words, we don't know anything about the numbers that follows that 1, right? There could be numbers there, but the way that we have it written down, we don't know. What we know is that we know that that's a 1 and that's a 1. That's what we know. There could have been 2 there, right? There could have been a 3 there. There could have been a 4 there. That's following it. We don't know, right? Because of that, that tells us that this number can't be significant, right? And so then you're going to use that as our separating point. So that's the reason why we draw the line. And we always take the one that's to the left, because that tells us the one that we know the least about. And that's the one that's going to dictate everything. Does that make sense? Okay. Because the way we look at it is that that number that gives us that least amount that we know about, that was the one that's gonna hurt us the worst. And so you're trying to take that into consideration. You wanna keep that data because when you're thinking about, you know, different areas, like getting data from different areas, when you're thinking about it, that data is valuable because it does have numbers that were significant. But we have to limit our overall data based upon that insignificance, the things that we're not sure about, that uncertainty, right? And so we're taking that into our calculations. So then what we're presenting at the end of the day is stuff that we're sure about, right? So we're so sure about this being greater than, you know, it's 1.016. We know about that, we're sure about that. Because we know that we have enough real numbers here that add up to be greater than that 5, right? So then we can make that decision, oh yeah, we can round it up because it's gonna give us a very closer number to what we think. Okay? Okay. Questions? Concerns? Yeah, that look.
There's like a number, the 2, right, and there's a 0.
You don't get that part? You said the 2 lines here. You're talking about the black line or you're talking about this one? I put 3 lines here. Yeah, the 3 lines up here, right? Instead of putting 4, instead of putting 2. So this one has 3 lines because we have three different points where significant ends, right? So in one case, this one here, this very first case, significant ends after the 1, right? And then this one, significant ends after what? Is it after the 2? So it's 2, 0, 1. So where does significant ends? Okay, so you're telling me, now I'm gonna repeat what you just said. So you're saying that this 2, right, is the only thing that we're sure about. Are you sure about that? Right? Because we have a number, we have a 0, we have a 2, 0, and a number. So we have a capital 0, and we have another number after that. Aren't we sure about the 1? Did we put a 1 there? I'm talking about on the second. The second number. So I'm talking about this one. Let me underline it. This one here. This number here, right? So how many sig figs do I have for that number? There's 3 sig figs, right? So significance would end after. Would it be after the 0?
Like the first one.
Okay, so you're saying significance would end after this first 0?
The one that's closer to the 2.
Right here.
Yeah.
Okay, so in that case, no, because that's where significance starts at, right? Because you just told me I have 3 significant figures, right? So are you saying only these zeros are significant? You're just looking at this number by itself. You're not looking at everything yet. So your significant numbers are non-zero numbers. So your 2, your 1, and then the fact that you have a 0 in between, that makes it significant. So significance begins at the 2, and it ends at the 1, right? Or are you just nodding to say yes, to say yes? You get that part? Okay, so then you draw it where significant ends. So after this, so we're sure about these numbers, right? These numbers are here are just placeholders. They're letting us know this place, so we don't have to take those into consideration. But we're sure about these 3 numbers, the 3 numbers, the 201 at the end. We're sure about this. Sorry, again, I need a point on the board. So we're sure about these guys right here. So we're confident about this because they're non-zero numbers, right? Or a capital 0, okay? Then after that 1, do you know what the number is? Are you psychic? Can you just say, man, that's an 8. I know it's an 8, right? You can't say that. We don't know that, right? So we don't know what that number is following the 1. We could assume that it's perfect and it's just 201, right? but chances are it isn't. It probably, if somebody else had another scale, they would probably get a different number, right? So, a better scale. That's right, the last number of significance. So I draw the lines after the last number of significance. So in this case, in this situation right here, at 0.011, we put the line, it's that green line, because that's the last number of significance. That is the last number that we know about, that we're sure about. Okay? And then the fourth case, it's after the 3. So that's how we ended up with 3 lines. Okay? Questions? Okay, so now that you have had all your questions, do the last 2 problems. Then we'll check. Then we're going to take a short break, a short listening break. So not next week, but the week following, you're going to have your first exam. Not next week, the week following, you're going to have your first exam. And it's going to cover your first 2 chapters, or first 3 chapters. Chapter 1, chapter 2 chapters. Okay, so let's go ahead and finish this. Okay, so I'm going to move a couple things around.
Can we use these on our quizzes?
You can use them on your quizzes, but not your exams. So the only thing that you guys can use on your exam, is that packet with the periodic table. Okay, so that is the only thing that you guys can use on your exam. Okay. So let's draw some lines.
He said next week.
Yes, next Wednesday, the practice exam will open. Next Wednesday, the practice exam will open. So you will have a week and a half to play with the practice exam. And then you also will have just a week to do your exam. Yes, yes, I would say it's very simple. So the more times you do your practice exam, the better off you will be. Okay, so for this problem down here, so that very first number, 20,120. One of those days. Okay, where does significant end? After the 2. Okay, the second number, where does significant end? After the 2. I have no idea why they both look weird colored. Something wrong with their screen. Okay, so we have line A. That's an A, really. And this is line B. Okay, so if we do the math, what did you guys get? 8,120. Okay, so what number am I going to use to determine whether I'm going to round up or leave it alone? The 1. Okay. Okay, so is 1 greater than 5? No. So then my answer is going to be 8,000. Okay, so the important part here is that we use the zeros to let us know that we're not sure, right? So we're not going to put a decimal afterwards. We're just going to put 8,000 because those zeros lets us know that we're uncertain, okay? And we wanna make sure that we keep that value. We don't wanna put 8 point something, right? We don't wanna put 8 point something because that isn't 8,000. Wouldn't you guys be a little upset if I paid you $8 and you really earned 8,000? Right? So remember, you're using the placeholders. The zeros are working as placeholders, and they're also letting us know that it's uncertainty associated. Okay? Okay, good. So the next question, what did you guys get for this one? Oh, where does the significant end? After the first number. After the. Okay, and then what about the second number? After the 1. Okay, so let's go ahead and do the math. So 0.9943. Okay? So what number are we going to use to round? We're going to use that 3. Okay? So then my final answer should be, let me type it because my 3rd grade handwriting ain't getting it today, so. Is that correct?
I think you said it was 1.0.
It was my bad because I didn't look where the number was at, so I had it all lined up wrong. I didn't know what I was supposed to do, so it's my bad. Okay, questions?
Why did you leave out the 3?
Yeah, what?
Because we're not sure about the number that's down here, right? So we don't know if that's a guaranteed 3, right? It could be more than 3. Could be 1 more than 3, could be 2 more than 3. It could be, so that after the 1, it could have been anything, right? Because we don't know. So that just tells us, so that's the reason why we draw the lines. The lines lets us know which numbers we're sure about, right? So that's the reason why we always go from the 1. Okay? Okay, so when we talk about say figs, we have multiplication and division. When we're doing multiplication and division, it's the one that has the least number of significant figures. That's going to be our answer. It has to also have the same matches. So like say, for instance, the very first question. 0. So this very first question. Okay, we have 0.001 times 2020. So in this context, we're going to determine which one has the least number of significant figures. How many sig figs do we have for 0.001? 1 sig fig. How many do we have for 2020? How many? 3? 3 is correct. That's right. So we have 3. So which is lower, 1 or 3? 1. So since one is lower, our answer is only gonna have one sig fig. So, let's go ahead and do the multiplication. What do you guys end up with? What did you guys end up with? $2.02. Okay, now we know that our answer is only going to be how many sig figs? Okay, so then that 2 is going to be that sig fig, so 0. Is that greater than 1? I mean, greater than 5 or? Okay, it's not. So then our answer is going to just be 2. Okay? Okay, so then it's going to be the same case for division. Okay, so if we have 231,500 divided by 10.0. So how many sig figs do we have for 231,500? We have 4 sig figs. And then 10.0? 3. Because I took the time to put that decimal point there and a 0 following it, that means it's significant. So I have 3 sig figs. So then my answer should have how many sig figs? 3. Okay, so let's go ahead and do the math. Okay, and you said I should only have 3 sig figs. So what number am I going to use to determine if I round up or leave it alone? I'm going to use the 5. Okay? So it's 5, 0.0. So what does that mean? It's going to stay the same. So my final answer should be, since 3 sig figs, 230. I'm sorry. 23,000. I'm sorry. Yeah, 23,100. That's going to be my final answer. Okay? Everybody sees that? Yeah? Piece of cake, not too hard? Because it's exactly 5. Remember, like the teeter-totter?
It doesn't stay 5, it's exactly 5.
No, it doesn't say 5, right? So you're gonna leave this number alone because this number decides whether we round it up, right? Or we leave this number alone,
Okay.
right? But then this tells us that we have uncertainty, right? At that point, because we only have 3 significant figures. 3 significant figures, that's the most that we can have. Okay, so. Does that make sense? Yeah. Okay. So this is just helping us understand uncertainty, right? So if you take a look, we have this board that we're trying to measure. Now, in that first case, do you see any measurements on the other board that's next to it? Right? So that means that we have complete uncertainty. We don't even know what it is, right? So we wouldn't be able to sit there and make any statement about it because we don't know what it is. So if we decide to sit there and put centimeters on there, right? So now we can sit there and make an estimate. Make an estimate. How big is that board? was that? 64, okay? 64. Can you say that for sure? No, right? But the one thing that we can say is that we know that it's between 60 and 70. So we're sure about what number? The 6, right? So the 6 is a 60, right? So we're sure about the 60 part. Okay? So let's say we actually did some more lines. And we get a better view of the board. So now we can say that it's 64. Okay, so we can definitely say that it's 64. But then we can't say 64 point, right? We can take a guess, but we wouldn't be sure, right? So then how many sig figs then in that case? That we're sure about, it's 2. Okay, so then we get even tighter, we get some millimeters in there, right? I'm still blind, I can't see there. Okay, so that's 64 point, looks like almost 2, but not quite 2. Yeah, there we go with this. Okay, so in this case, we get a little bit closer. You have a question? Yeah. Okay, so in this case, we're able to sit there and say definitely it's 64. 64 point something, we can't say. We can't get it that tight. But we know that it's greater than. I have to look really close. What, 61? Oh, wait, 61 point, or 64.1. It looks like 64.1, right? A little bit more than 64.1. So we're sure about that. So it's anywhere between that 0.1 and that 0.2, right? So the things that we can sit there and say, can you guys see that, or am I making things up? You should give me that one. Am I making it up? What do you see? Come on, get up here, get close, so you can see it. So here's 64 point, and there's 1 centimeter, 1 millimeter, 2 millimeters. So the 1, we're past the 1. You see it? So I'm not making things up. I am blind, but not, I guess not that blind. Almost that blind. Okay, so the point is that sig figs helps us with that answer. That's the whole point. Push it. Okay, so recap. How many sig figs for that first one? How many for the second one? Piece of cake. So basically, what happened to our cake? Notice you still haven't brought it. They cut this. Okay, so we've already talked about how to round it. So you guys already know how to do rounding, right? So the confident? You don't, you have to do those. Okay, so in this case, what we're going to do, we're trying to calculate, it says, specific ways of bigger and 4 different chemicals using different balances. The individual masses and their sums are, the beaker was 319.5 grams. The chemical A was 20.460 grams. Chemical B was 0.0639 grams. Chemical C was 45.642 grams. Chemical D was 4.173 grams. And then they actually give you the total, right? So you don't have to do anything. All you have to do is line everything up. What are you supposed to do? If you guys are trying to figure out how many sig figs that you should have for this answer, and then the answer, including the answer.
Put them in the order you do it.
Okay, so we're going to put them in order that we're going to do. And then we're gonna line up everything. Okay. So, if we line up everything, we know that significant for the entire problem is gonna end at this point, right? Because significant ends after the 5 year, significant ends after the 0. Sorry. Significant ends after the 5 here, significant ends after the 0 here. Where does significant ends here? After the 9. And then here, after the 2. And then this last one, after the 3. So this is going to give us our closest line from the left, right? So then we're going to use what number to decide whether we round up or we go up. So we're going to use that 3. Okay, is 3 greater than 5? No. Okay, so then your final answer is going to be 389.8. Okay, questions? No questions? Okay. So we've already talked about multiplication and division. About that anymore? Okay, so recaps. So the metric system compared to the US customary system or the empirical system. 1 inch is going to be equal to 2.54 centimeters. So that's one thing that you guys want to try to keep in the back of your mind. If you guys look on your sheet, there are a couple of things on your handout, not your packet, but on your chemical packet. Yes. Second page, you have a lot of conversions there. Third page, you have some of the conversions there. Okay. So we provide you with some of the conversions to make it easier for you. But the more you use it, the more it'll stay up here. Okay? So let's say 1 pound is approximately equal to 453.59237 grams. 1 gallon is approximately equal to 3.7854111784, and that's actually exact if you want it to be exact. Often we round it, we go 3.785 because we're a little lazy and don't want to include all those numbers. Okay, so you guys are already familiar with the US customary system and how they relate to each other, right? 1 foot equals 12 inches, 1 yard equals 3 feet, 1 mile equals 5,280 feet. You also know that 1 mile equals 1,609 yards. And 1 pound is 16 ounces. 1 quart is 32 fluid ounces. 1 gallon is 4 quarts. So knowing all of that, the soft drink manufacturer is converting from US customary units to metric units. If a bottle is initially, let's say, if a quart bottle initially is to remain the same volume, what is the number of milliliters that should be printed on the label? Okay, so what's going to be our given? A quart. So what do we know about the quart? What conversion can we use? 32 fluid ounces. Is that going to help us? Because we want to go from a quart to milliliters. But you're right, I'll put it on the board. So we know that 1 quart is equal to 32. Flow analysis. Okay, anything else that we know about the quart?
6, 4 quarts, maybe not.
4 quarts make a gallon. Okay, anything else that may help us? Because we want to go from from the US customary system to the metric system. Okay, so 1 gallon equals 3.785 liters. Okay, so you think this is going to help us right now? Probably not. What about this one? Okay, so if we have this one, we have quart on top, so what should be on the bottom? What should the quarts? Okay, so I'm going to put my quarts down here. So that means our gallon's going to go on top. And then we're going to put those values. So the value for the quart was 4, and then 1 gallon. Okay, so then quarts cancel out. Okay. So there's the question. Okay. So there's a remind me to answer the question about the notes on the exam after this. So we get quart canceling out, and then we have gallons. Okay, so what do we do to get rid of gallons? We're going to do to get rid of gallons.
Cancel it out.
Well, how are we going to cancel it out? We're going to put it.
Like checking it.
Okay, so I'm going to put gallons on the bottom. So I have 1 gallon on the bottom. And 1 gallon is going to equal to how many liters? Okay, so the gallons cancel out. But, okay, we want milliliters. So what is the relationship between liters and milliliters?
1 liter.
So 1,000 milliliters equals 1 liter. Okay, so if I want to get rid of my liter, let me see on the bottom, let me see on top. 1 liter on the bottom, 1,000 mils on top. Okay, and then we just multiply everything, right? So we multiply across, we have 1 times 1 times 3.785 times 1,000 divided by 4. What do you guys think that was? Is it 946? Okay, question. So I'm going to ask you a question. Do I have to be concerned with sig figs in this case? Yeah, no, maybe. One quart. Is that an exact number? It's an exact number, right? So in this case, I don't have to worry about sig figs. I can look at whatever sig figs I want to, right? So it's no longer a concern for us because we started with 1 quart. Everything else is a conversion. You don't use conversions to determine your significant figures. Does that make sense? So if they give you an exact number, then 1. Then in that case, you don't have to worry about the number of sig figs. Okay? Makes sense? Yeah, no, maybe. Let's see. So there was a question earlier that I didn't answer. So the question was, are you guys allowed to use your notes on the exams. No, you're not allowed to use your notes on the exams, but you can use the chemical package. For those who are online, there is under modules, there is a packet that says chemical packet. You can use that packet. Everything in that packet is fair game to be used on the exam. So it has a lot of your conversions. It has your periodic table. It has lots and lots of other information that you'll be using throughout the semester. Okay? Any other questions about the exam before we move ahead? When are you gonna do it? Okay, so the exam is gonna be due in 2 weeks. So next week, your practice exam will open up on Wednesday, next Wednesday, which is, let me give you an exact.
So quiz and exam are different?
Yes, quizzes are different than your exams, yes. Okay, so sometimes I'll throw a quiz just to throw a quiz. Quizzes can happen at any point. Today I can give you a quiz if I wanted to, right? Exams are, I'm giving you an opportunity to study for things, right? So then exams, you have a little more leeway, okay? So on the 6th, your practice exam will open up. And then it's gonna be due Saturday at 11:59 p.m., which is the 16th. So September 16th is when your first exam will be due. Okay? Can you use your notes for your quizzes? So yes, you can use your notes for your quizzes. And sometimes you can use your name. Not for the answer, but to discuss some. Okay? I'll let you guys know specifically when that happens. Any other questions?
So what we were talking about earlier, that you're gonna open up as a exam.
It's an exam, yeah. So you don't have a quiz coming up. Usually I give quizzes, but I think you guys are slacking. You know, if I think you guys are you might answer questions, then I give you a quiz. Because a quiz does 2 things. One thing, it keeps you guys on your toes. The second thing, it lets me know what you guys are learning and what you're paying attention to. Any other questions? Yes.
Are you gonna open up the exam after a week of the practice class?
No, the exam, okay, so the practice test will open up on Wednesday. So the exam will officially open up on that Saturday after the practice. So then you'll have an entire week to do the exam, right? So you have from Saturday to Saturday to do the exam. Okay? Yes. Of course, everything, so you get points for doing it, right? So here's the secret, and I'll tell you what people do, right? Most of my practice exams, if you open it up, we have 2 questions, it pretty much gives you all of once, right? That's what a lot of people end up doing. But then they do that, and then they get to the exam itself, right, which is 30% of your grade, 25 or 30%, one of those. So in that case, they get killed on the exam because they only get 2 problems. But yes, it does. And it's considered part of your quizzes and that area. So that's only what 4% of your grade, 4 or 5% of your grade. I can't remember off the top of my head. It's in your syllabus. Yes, 1 and done. Yes. Okay. So that's why you want to study. And the thing is about your practice test, you can actually do it as many times as you like. You know, make multiple attempts. But you gotta submit it, you know, submit, and then that'll open up another exam for you to practice with. Sometimes there'll be different questions, sometimes they'll be the same questions. Okay? Any other?
It tells you when you're right, but not the right answer.
Yes, it tells you if you're right, but it won't tell you what the answer is. So I want you guys, part of that is to let you guys interact with your tutors, right? Because if you're struggling with something, I want you to interact with your tutors or interact with me. You know, I will start giving you guys my official office hours now that all my classes have started. You kind of have an idea of where I'm gonna have availability. My online class, I'm setting up some additional Zoom meetings for them so that they'll have availability as well too. So you guys will be sharing, so you guys will have that opportunity. You guys all know that on Saturday from 7 to 9, that's kind of like an office hour. It's cocktail hour. Come in, talk about science or whatever. It's also right before your homework, right? So if you guys get in the habit of at least getting the hour of your time coming in, you learn a lot, even if you may not ask questions. I had a student, look at that, she was there she would never ask one question, not one question. She had the highest grade in the class. Because everybody else was asking questions, and so she was just taking notes that whole time. You know, she was too shy. But don't be shy, because if nobody asks questions, then I just sit there and I talk. You know, talk about my ex-girlfriend, talk about drinking, talk about a lot of things, right? It may not be anything that you want to talk about, so, but you guys gotta guide me by coming there and asking questions. Okay? Saturday night, I would prefer doing other things, but I'm dedicating to you guys because I want you guys to do well in this class. So if I can dedicate my Saturday night, you can dedicate one of your Saturday nights every once in a while, right? Okay, good. So let's move on, because we need to get through this chapter, because I need to start getting through chapter 2. What time is it, by the way? We got another, what, 20 minutes? 30 minutes? 40 minutes? Something like that. Okay, so we also need to be able to convert for temperature. The temperature that we use in science is often Kelvin, but often we'll also use Celsius, you know? Celsius is the temperature that most people around the world uses, except for us, we have a need for Fahrenheit. So to do the conversion from Fahrenheit to Celsius, you're going to basically use this equation. If you guys take a look at your packet, I think it's the 3rd page. It's the Army symbol on the bottom. At the very top corner on the right-hand side, you have your conversion for temperature. You guys see that? So all it is plugging in and making sure that you enter it into the calculator correctly. So for instance, if I put 112 in for Fahrenheit, I mean not 112, 212 in for Fahrenheit, what should be my value? 212 for Celsius. For the temperature in Fahrenheit, into this equation right here, this equation right here, if I put 212 in, so 212 degrees Fahrenheit. Okay, so just going to plug it into the equation. So minus 32. And then I'm going to divide it by 1.8. And that's going to give me my temperature in Celsius. What do you guys end up with? Okay. And so if we wanted to go from Celsius to Fahrenheit, we're just going to rearrange this equation. Okay, so we get 1.8 times T Celsius, or temperature Celsius, plus 32 is gonna equal what we get for Fahrenheit. So the way I like remembering it, I always know that Fahrenheit is greater than Celsius, because 25 degrees Celsius, 25 degrees Celsius, or 22 point something, 22.5, is approximately equal to 72 degrees, right? So that's how I remember, or I also remember that 100 degrees Celsius is going to be equal to 212 degrees Fahrenheit. So I always know it's greater, so that's how I know that plus 32. So. Okay, questions, concerns, Dash? Okay, so the absolute temperature scale is Kelvin. So we use Kelvin to sit there. Take a step back. Okay, there we go. Okay, so at absolute zero, everything stops moving. Okay? At absolute zero, everything stops moving. And that temperature that everything stops moving at is negative 273.15 degrees Celsius. Okay? So negative 273.15 degrees Celsius. How cold does it get here? What is the coldest it get? So So 53, 55 Fahrenheit, right? Fahrenheit. So do me a favor, convert that to Celsius. How would you convert that to Celsius?
Times the Fahrenheit.
Okay, so 1.8. Is it 1.8 times? If we're going from Fahrenheit. So we have 55 degrees Fahrenheit, right? And we know that that was minus 32. And divided by 1.8. Okay. This is going to give us our T in Celsius. Okay, somebody do that heavy lifting for me.
12.7.
Okay, so coldest it gets here is 12.17 degrees Celsius, right?
12.7.
12.7, I'm sorry, 12.7. Okay, 12.7 degrees Celsius. Okay, now could you imagine negative 273.15 degrees Celsius? Right? We know that ice freezes at what temperature in Celsius? A little bit more. Say it again. 0. Oh, I thought you said 2. Oh, my bad. What? Oh, okay. I'm sorry. Talk up then, so I can hear you. So 0 degrees Celsius, that's right. So we know that ice freezes at 0 degrees Celsius. This is 273 degrees below 0 degrees Celsius, right? So in that case, everything freezes. So that's why it's called absolute 0. So Kelvin, when Kelvin, 0 degrees Kelvin, that's going to be the equivalent of negative 273.15 degrees Celsius. So that's important to us as chemists because we know that every molecule, everything stops moving at that. Everything increases at that. Okay? So that's why we call it absolute 0. So the conversion, because we want it on the absolute 0 scale, we want to convert things to Kelvin. Okay? So if I wanted to put 12.7 degrees Celsius, and I want to make that into Kelvin, then all I need to do is add 273.15 to that to put it on the absolute 0 scale. So what is 12.7 degrees Celsius in Kelvin? Okay, what equation am I going to use? Well, 12.7 plus 273.15. What does that equal? And the thing about Kelvin is that we don't use the degree sign. Having trouble. Okay, so this is just comparing all 3 scales. So you have the Fahrenheit scale, you have the Celsius scale, and you have the Kelvin scale. Okay, so then it lets us know the distinction between all 3, right? So at 212 degrees, that's equivalent to 100 degrees Celsius. 100 degrees Celsius is when water boils. Water freezes at 0 degrees Celsius. That's 32 degrees in Fahrenheit. And that's equal to 273.15. Okay, questions? Yes.
Who exactly figured out the Kelvin scale?
Oh,
But that doesn't sound like, that doesn't sound like something that purpose.
that they did on purpose?
Yeah.
Oh, it was something that they did on purpose?
Does it sound like freeze a bottom file?
Yeah, probably. Well, so they actually did it on a small component, right? And then they extrapolated. Right? So they started looking at the resonance, and they based upon taking a look at the resonance, then they make the extrapolation. That's initially how it's done. Now we can actually we got enough power that can be generated to get to that level, but in a small scale. So we've confirmed it since then. Okay. So before it was just an extrapolation. They were like, okay, so we can get to this goal, so we're getting this much resonance, this much resonance, this much resonance. What I mean by resonance is movement, right? When you put the molecules. And so then they determine when movement they're saying, okay, so if we continue, then we should get no movement at this point, right? And that's how we do it. Yes, that's a good question.
So, when we did 55 Fahrenheit to Celsius, you got 30, you subtract 32 because 32 degrees.
Yes, yeah, and so that's our number that we got from it. So calculations, to create the scales, that's how they determine, so 32 is our piece of in Fahrenheit. Any questions?
We talked about the 273 is a breaking point.
No, so negative 273 degrees Celsius is equivalent to 0 degrees Kelvin. 0 degrees Kelvin is when things stop moving. That's absolute zero. Does that make sense? And so your book often will just leave it at 273 instead of putting 273.15. I always put 273.15 because I like to remember that 0.15. Okay. Thank you. My computer's just not working with me today. Keeps freezing. Okay, so convert 288 degrees, 288 Kelvin to Fahrenheit. Okay, you guys ready? You guys got it? Okay, so the first thing that we want to do, we want to convert it to Celsius, right? Because we know the conversion between Celsius and Fahrenheit. So then you're going to just add your 288. And then you're going to subtract your 273.15. And then that's going to give us our temperature in Celsius. Okay? What do you guys end up with? Like 14 point something. $14.85.
Why did the positive switch to a negative?
Because we put it on the other side of the equation.
Oh, you did it both.
Yes, I was showing you both equations. So to change from Celsius to Kelvin, we just add 273.15. So then to change back from Kelvin to Celsius, we just subtract the temperature of Kelvin to this. Does that make sense? So all I did was I brought this on the other side of the equation. So when we do that, it causes it to be a minus on the other side of the equation. Okay? So then that's how we ended up with this equation here, and then we just plug that in. And then that would be degrees Celsius. Okay, so then we're going to use this to plug into our equation that determines Fahrenheit. So TF, the equation is TF equals 1.8 times TC plus 32. Okay, so if we go ahead and plug that in, 1.8 times 14.85 plus 32. That should equal 58.73. I'll move it over here so you can see the numbers. And the units would be in Fahrenheit. So, degrees Fahrenheit. If I can get it over enough to put it. Okay, so that way we do this. Questions? No questions? Concerns? Yes.
Like, if we look at it, as on a computer, when we have to round it up.
So sig figs with this one. So this is a little harder one, right? In that case. So in this situation, you're using an equation. So in most cases, I won't hold you to sig figs in this situation. Because usually the sig figs that you're starting off with is what's going to be sig figs you're going to end up with, because you're using the equation as a conversion, right? So if we started off with 3 sig figs, so then just end with 3 sig figs. Just for simplicity basis. Okay. That's a good question. Very good question. Okay. 6 minutes. Let's see. I think I have a little bit more to go. So I guess we're just going to table it to the beginning of the next lecture. 5 slides, 6 slides, 7 slides. So we'll start back up on Monday. I mean, not on Wednesday. Thank you.